Hi, everybody. Welcome to today's online meetup, Powering Data Science and AI with Apache Spark, Alluxio, and IBM. Today, we'll also be featuring a leading telecom use case. My name is Amelia, and I will be your moderator. Before I introduce you to our speakers, I just have a few housekeeping items. All participants are automatically on mute throughout the session. We will be using Slack to communicate, so please take a moment to join us on the community Slack channel, which is alluxio.io/Slack. It's also copied into the chat box. However, if you are having trouble joining Slack, feel free to message me your questions instead, and I will share it with the group. And you can send me your questions by looking at your GoToWebinar control panel under the Questions section dropdown. Today's session will be a great presentation by our two very special guests, and we will have a Q&A session at the end of the presentation so we can answer all of your questions. However, don't hesitate to send me your questions anytime throughout the presentations or post it into Slack. Lastly, today's session is being recorded and will be available for on-demand playback. We will be emailing out the link to the presentation in a few days. So in the meantime, let's start off with doing a poll. I've gone ahead and launched the poll here. What is your level of experience with Apache Spark? We're just going to give this a couple of seconds. All right, we got quite a few answers rolling in. I'm going to close the poll in 5 more seconds. Okay, let's look at the results here. Pretty interesting. We got a pretty even split between exploring Spark, using it, and using it in production. Great. Well, today's topic will be very relevant and interesting. All right, so that's it on the housekeeping items. I will go ahead and let Haoyuan, who we call HY, who's the founder and CTO of Alluxio, to introduce our speakers.
Great. For today, we're very excited to have 2 speakers with us. The first speaker is Yonggang Hu. He's a distinguished engineer, chief architect at IBM Spectrum Computing. He has been working on distributed system, great cloud, and big data for the past 20 years. Before joining Spectrum Computing, Yonggang was a VP and application architect for JP Morgan, focusing on computational analytics and application infrastructure. He holds a master's degree from Peking University and MBA from Cornell. So joining Yonggang, we also have Bin Fan, who you guys are all very familiar with. Bin Fan is a founding engineer at Alluxio and a PMC member of the Alluxio open source project. Before Alluxio, he has worked for Google, where he won Technical Infrastructure Award, and also he has received his PhD in computer science from Carnegie Mellon University, working on distributed system. Without further ado, so we are pleased to welcome and pass on to Yonggang and Bin for the presentation.
Many thanks, Haoyuan, for the introduction. Today, we have 3 items to talk about. At first, we're going to talk about why we want to decouple the compute and the storage, why we need the storage independent compute. And then I will talk a little bit about IBM Spectrum Conductor technology, how to orchestrate and manage workload. After me, Bin will start with Alluxio technology overview and all the benefits from Alluxio technology. At the very end, we will talk about a real-world use case. We will jointly talk about the customer problem and also experience. We all know there are a lot of data, the data from cell phone, data from Facebook, Twitter, but there are also a lot of data from a connected car, connected vehicle, connected devices. And if you look at the bottom right, amazingly, you will see there's a 1.7 megabytes of data generated per person per second. And think about 20, 30 years ago, the floppy disk only have 1.4 megabytes. Right now, every person on this planet, every second, will generate 1.7 megabytes. So there is a problem. On one hand, there are a lot of data available for the enterprise. On the other hand, there are very little being understood by the people and being useful for the enterprise. And quite often, this gap is being referred as enterprise amnesia. The question is whether how we can create an effective, scalable data engineering toolkit and the capabilities, and also with latest cognitive and AI technologies to move up to the bottom curve so that enterprise will understand the data better and then also unlock more business value. Let's look at it from a different perspective, look at from a computation requirement perspective. The AI training compute demand keep increasing at a rate of 3.5 months doubling since 2013. And if you look at the graph, there's a certain correlation between the models and also the compute demand. This is not linear because this is a log scale. This compute demand increase at an exponential rate. And if you remember Moore's law, it talks about the transistor density doubled every 18 months. And if you apply the 18-month rule from AlexNet to AlphaGo 0, you would get 12 times the increase. But with a 3.5 months doubling speed, the actual increase is 300,000 times. So this is the situation. On one hand, there are a lot of data. On the other hand, there's significant increase of compute demand. And different workloads have different characteristics in terms of data and compute. Let's look at a little bit challenges faced by enterprise customer during the production. There's for sure elephant, and actually not just one. There's many elephants. We heard from our customer, they talk about there are many small Hadoop cluster not really doing useful work. And also because of the stack, and also because of the number of cluster, it introduced a lot of complexity. The operational cost to manage the environment also high. And this is interesting. A few years back, when I visited a customer, a big bank, they told us there's no data locality from HDFS. We did some analysis to try to understand why, and we found out the data access pattern schema in enterprise is very different than what Google, Yahoo, Facebook has. Google, Facebook have a lot of data, large volume data, but it's high density, low dimension. Well, on the other hand, the enterprise have relatively small data, but it's very high dimension and also very complex, sparse data. So once you have this complex schema, once you have application, need to load the data from all the different data sources, different table. Once you have many users using the environment loading data, once you have one application need to access multiple pieces of data, then it's very hard to achieve data locality. And then we also been told by our customer saying, oh, data scientists cannot really run analytics in the data lake. And there might be multiple reasons. One is sometimes when you put a lot of data into Hadoop, the Hadoop cluster becomes too critical. At one customer, they have multiple petabytes. They said, oh, we really cannot do upgrade to new version of Spark. And they have to still running the very old version of Spark. And also from other end, right, from a data scientist perspective, they also afraid of messing around the big production environment, and they're also afraid of their job cannot get timely response, especially running interactive workload, because quite often when you run big, large batch workload, the batch workload taking over entire cluster. And for the ETL workload, quite often I heard a question from customer. They ask why they need to copy the data to data lake first before running ETL. ETL is supposed to be transient, supposed to be in memory, supposed to from one source to one destination. In-memory compute will make a lot of sense. Copy to data lake first, just add additional overhead and the complexity. And sometimes, quite often, the Spark AI workload also compute intensive, and people are asking about independent scaling of compute and storage. Spark is just fantastic. Spark solve a lot of problems. If you look at the trend on the right-hand side, you can see there's a downward trend for Hadoop, while Spark keep going up for the past few years. And there are also predictions that Spark will dominate the big data landscape by 2022. This is mainly because a lot of the built-in capability from Spark is in-memory compute, a lot faster than MapReduce, and also it enabled the decoupling of compute and storage. Actually, this decoupling is not really new. It was predicted by O'Reilly even 2 years ago, more than 2 years ago. Every year, O'Reilly at the beginning of the year make a data trend prediction. One of the big trends O'Reilly point out is decoupling of storage and the computation. And this is mainly enabled by Apache Spark and Alluxio. Alluxio is a topic we're gonna talk a lot today. And this is also driven by the fact of cloud adoption, using object store in the cloud, because in the cloud you don't use hyperconverged architecture using local disk. You have to adopt compute storage decoupled architecture. And this is further enhanced and driven by the deep learning architecture and the demand. So IBM definitely are very committed to open source. We have open source team contributing Linux, contributing Kubernetes, and also have a significant contribution to Spark community. We have a dedicated team on Spark contribution with 4 committers. You can see over the past year, we contributed in many areas: Spark SQL, PySpark, Spark Core, ML, etc. Besides the open source contribution, we are also working with a lot of large clients, try to solve some of the real world problems in enterprise deployment to make a large scale Spark deployment reality. So we address several areas of challenges. Bottom left, we introduce a better workload management, really allow users to control application SLA and improve the utilization and throughput. On the top right, we also realize that you cannot just deploy siloed environment for Spark. We want to build customer want to build a shared service environment to support multiple Spark team, multiple Spark application instance, all working together using shared service, so that it can improve the server utilization and also reduce administrative overhead and a better application SLA. To move the Spark to enterprise, we also need to provide a better reliability, better HA, and better security. Specifically, we have faster Spark, with significant innovation and optimization in workload management domain and also Spark core. And also, we talk about this acceleration not just on-prem, but also available on the cloud to enable cloud bursting using cloud resources dynamically. We like to eliminate class sprawl and provide multi-tenant sharing infrastructure so that you can improve utilization, have a better SLA. Over there, we need to support multiple instances of Spark, different version of Spark, and also provide isolation. From administration side, we want to streamline the deployment, different versions of Spark and the Conda, Notebook, provide integrated monitoring, reporting, troubleshooting, event mechanism, so that user can quickly onboard the most Spark application running in production. First thing first, we like to help the enterprise customer to break the silos. Running siloed deployment for different Spark applications is inefficient. If you can aggregate the results and then provide access to all those line of business, that will be an ideal situation. But the key over there is you have to maintain application SLA. Otherwise, nobody would like to use the results from shared tool. Scalability also important. We have some unique capability to enable such flexible sharing with a guaranteed application SLA. We have a very unique resource plan capability where you can express the sharing policy across the different lines of business and application in a hierarchical resource plan. And this hierarchical structure represents the organization structure and also application hierarchy. Over there, you can define how much CPU memory resources being owned by each application, and at what moment application can share the results with other line of business, and what moment application can borrow results from other line of business or application. And you can also bring in time dimension at a different time of day. You can define different policy and ownership. In addition, we also introduced the prioritization for Spark. We had a talk last year at Spark Summit, and this is the first time ever in the industry we bring the prioritization and advanced scheduling policy to Spark workload. We support first come first serve prioritization and also fair share policies. With fair share, with prioritization and resource plan capability, user can use the resource pool resources from resource pool dynamically, but also with a guaranteed SLA. If there's no workload from certain applications, they created a bound, then the result can be utilized by other line of business or application. However, when the application, the owner have a workload coming in, we can trigger permission and reclaim to have a guaranteed execution for the mission critical workload for the specific line of business. With this advanced resource management and workload management, we deliver faster results. This is a performance benchmark created by IBM, and we also open source it. Also presented at the Spark Summit, and the benchmark source code are all available. And this is audited by a third party called Stack organization. We mainly compare on two dimensions. One is throughput and performance. You can see the green bar is a Spectrum Conductor. We can finish more jobs per hour for different use cases: synchronous, interactive, asynchronous, multi-tenant, multi-user. And in addition, we also measure the predictability, whether you can run your workloads in a deterministic fashion, Over there, we measure the relative standard deviation. And this will give you a visualization. This is one of the use case. This is synchronous interactive multi-user use case. Every single dot on the picture represents a job. Job can be large and small, can be a query a few seconds, or can be a batch workflow running hundreds of seconds. And we run hundreds of such concurrent stream of workloads together in the cluster. What you can see here, the blue dot, which represents the Spectrum Conductor, running much faster than the alternative, Yonggang and Metals. And what you can also see is it's more consistent without a lot of outliers. Notice that this is a log scale on the y-axis. What you don't want is your job supposed to finish in 100 seconds, but in the end finish in 10,000 seconds, and that will breach the production SLA. We also added a GPU support. GPU is very important for a lot of AI workload. We actually brought the GPU support to Spark and AI workload in 2016. At a different stage of the Spark pipeline, we can determine which one can run on CPU, which state can run GPU, and allocate the GPU and CPU results dynamically. So this is a picture, a shared pool of results, and then you have a different application group, LAMP basis, access the shared pool of results, run the application. From an user perspective, when user using it, almost as if it has their own Spark cluster, virtual Spark cluster. They can use their own Spark version, notebook version, with their own authentication, authorization, user permission, and the data source. And when the LAMP business using resources, and the results are being allocated dynamically. If nobody running any workload, there's zero cost to the LAMP business, zero resource allocated to the LAMP business. Whenever the LAMP business application group have workload running, the results will be dynamically allocated to the LAMP business application to guarantee the performance and the application SLA. To support multi-tenancy, we also need to support data and application isolation. Not only we provide data result sharing on-prem, we also bring it to hybrid cloud and the multi-cloud. On-prem, you can do the sharing, and then you can also dynamically add in resources from cloud. Conductor can also be deployed to the cloud dynamically, so that it can do the auto scaling to dynamically flexing up and down based on the Spark demand and the policy. We support Spot instance as well. And this solution is to support multi-cloud, meaning that it can use multiple clouds simultaneously, and also can be moved from one cloud to another. So quickly, a couple of use cases. One use case is user already have a very large data lake, and the data lake will be continue to be the storage environment. And the conductor, our customer set up a conductor as a separate environment. They call it Spark Analytic Grid or Tier 0 Analytic environment. Over there, it has a better performance and also in-memory processing. It runs all the different type of workloads, Spark, Python, H2O, AI, and it's storage agnostic. It can load the data from a data lake where we support Kerberos and all the other data isolation and authentication, and also can load the data from other data sources. With our strong results and the workload management, we provide better utilization and better application SLA. Another use case is in financial services domain. There are a lot of regulatory reporting requirements, such as the CCAR, such as FRTB, such as the CISO. Over there, they need to doing large data analysis, running a lot of the model and generate a big result. And then later on, they need to do aggregation and reporting. But this is not just a one-way aggregation of reporting. Actually, they need to do aggregation on many dimensions, by trading desk, by country, by asset, by currency, and then they also need to support all the business analysts to do ad hoc query. One of the solutions we're working with our partners to implement is to have this shared Spark service, but also with this caching layer. Caching layer allow us to cache results, and then the same, say, P&L vectors can be used by different user, different application, different business analysts to do different aggregation and also support different ad hoc query. With this shared in-memory architecture, it provides a much better performance. In one case, we have seen a query performance from 8 minutes down to 8 seconds. The last use case I want to introduce is ETL. ETL, as mentioned, is supposed to be in memory. It's supposed to be streaming. It doesn't make sense to copy data to the lake before you run ETL. So that's why it makes sense to create decouple the compute and storage architecture to run all the different stream ETL in memory to implement ETL as a service. So that's all from me. I will hand over to Bin for this important caching layer from Alluxio.
Yeah, thank you, Yonggang. So Yonggang has presented a lot, very, very good information about what you can do with a Spark and in a new world. So, and it's very emphasized on the workflow side. In the later part, in the second half of this talk, I'm going to talk about a little bit more on the data side. So since we mentioned the data locality a lot, in the new architecture, especially driven by the cloud migration, cloud adoption, how can you guarantee the good data locality in this kind of compute or data intensive workloads? And how can you provide an easier interface for users and applications so they can get a great use of Spark to make it very simple to access data in different sources? So that's going to be the focus for the second part. Okay, so yeah, so we have something called Alluxio, that's the open source technology. And the challenge we see in the field for independent scaling for data architecture, for data application, is really in two different aspects: in data locality, and also, as I mentioned, and also in data abstraction. How do you build a storage abstraction so different applications can access data from different locations without even knowing where they are accessing? But also the data accessibility, so data can be accessed using the specific data APIs and without very easily. Next slide. That's why we want to build Alluxio. And essentially in the new ecosystem, we see more and more compute systems, including Spark, and also in some other domains like Presto or Flink or Hadoop MapReduce, Kafka, Hive. But also we have seen so many different data storage has been used for users to leverage the different in their different parameter space, in budget or in the cost or in the performance. So that's why you are seeing a lot more users are using different choices. Next. So we want to build a layer in between, and that's why Alluxio is born. Originally, Alluxio, you can think it as a sister project for Spark in UC Berkeley AMPLab, and was the PhD thesis from the student Haoyuan Li, who introduced me and Yonggang in the beginning of this talk. And in the very beginning, Spark is using Alluxio as the in-memory off-heap distributed block storage systems. So prior to Spark 2.0, if you do Spark to cache data off heap, basically it's using Taikan, which is the previous code name for Alluxio, to store this data. And later on, this becomes an open source project itself, and also we make it more general purpose, not just working with Spark, but also working with other applications, including Presto, including TensorFlow, using different APIs. And this project itself is getting backed by the top VCs from the Valley, like Andreessen Horowitz. And also along the way, we have a lot of industry recognition about this open source project. Next slide. Yeah, so this is a fast growing open source community. We have more than 1,000 contributors on GitHub, and with more than 4,000 GitHub stars. The project itself is under Apache 2.0 license, which is very widely used in the data ecosystem. And we have the Slack, community Slack system, community Slack channel. You can access the expertise from the maintainer team on the Slack. So for this particular webinar, if you have any question, feel free to raise your question in the Slack channel, and we will be happy to help you there. And the source code is served on GitHub. Next slide. Yeah. So this is what Alluxio is. We have Alluxio as the virtual file system in the virtual data orchestration layer in the middle, and it's basically providing different APIs to the applications. Popular APIs including Java API or HDFS compatible interface, or even S3 interface. We also provide the POSIX interfaces, so legacy applications or even the trendy machine learning applications can talk to Alluxio just like using a local folder. In the southbound, we provide a set of different built-in drivers or connectors. So Alluxio can talk to different storage services, storage devices without even transparently, without letting the user's application know. Essentially, the application is accessing the data, a logical file system, and without worrying how I access the data and where data is really stored physically. Next. So if you are interested, as an engineer, if you are interested in how to interact with Alluxio, so this slide gives you a rough idea. If you're using Spark or Presto, so essentially you just replace Alluxio HDFS to Alluxio, because that's basically the Alluxio provides the HDFS compatible interface. And from the application's perspective, they're just talking to a different implementation of Alluxio. So, and we also have the POSIX API, so you can have the Alluxio service to be mounted as a local folder, as I mentioned. So applications like TensorFlow or your familiar Linux or Unix bash tools can leverage this to access data. And we also have the Java API. So it is very easy to, if you want to leverage the full feature of Alluxio, this is the way to go. And this provides all the functionality provided in Alluxio. Next slide. Yeah, so this shows you how to convert, Alluxio converts the client-side API cost into their server-side API cost. On the northbound or the application-facing side, you can pick whatever applications interface you like, as mentioned. And underneath, so basically Alluxio can provide a HDFS interface to Spark, where the data is actually on S3. So you mount the data buckets in S3 into Alluxio namespace, but underneath, Alluxio servers will choose the S3 as using the driver to fetch data or to push the data to S3. And then from the user's perspective, you are just still using the HDFS, but underneath, it's already using a different driver. Next. And this shows you another feature widely used for Alluxio, and because we provide indirection between the application and also the storage. That means we have a chance to provide a logical view for the data. And right now, this logic view is a logical file system on top of files, other file systems, or object stores. So essentially, in this case, you can mount a S3 bucket into the Alluxio namespace, and you can mount another HDFS. So two different systems, two totally different systems are mounted into a single Alluxio namespace, and the users have no idea like which one is talking about. But just talking to this logical file system is good enough. That's sufficient. This can simplify a lot for the users to really focus on developing the logical rather than dealing with the heavy lifting, moving data around, or choosing the right client jars, or choosing the right libraries. And also it opens up opportunity to leverage Alluxio as a transparent naming layer as a federation for multiple different systems. So if you have one system in the S3 or in the cloud, and you have another part into different cloud vendors. So then from users' perspective, you're actually leveraging two different cloud systems. So basically the way to implement a multi-cloud system. Next. Yeah. Another feature from the user's perspective is really having a faster or low latency performance queries. And that's basically implemented by having Alluxio in the middle as a caching layer for Spark or for Presto. And the further the data is from applications, which is getting more and more common in the cloud environments, because your data is really in a different service like S3. In this case, having a distributed caching layer here helps a lot, because you can put the data, you can take advantage from the data temporal locality and having the hot data in the Alluxio space while you leaving all the entirety of the data in a cheaper but persistent storage. So that is a very interesting observation people have in the industry is typically you have only 5% of data hot, like accessed frequently, and 95% of the data is actually cold or like very silent. So you don't have to put them in the more expensive media like a memory, but leaving the memory space or resource to something very hot. And that's basically where Alluxio can help to put this type of data closer to the applications versus leaving the entirety of the data to some cheaper storage. Next. Yeah, so essentially this is the reference architecture, and you can see this from this diagram that the architecture for Alluxio is very similar to other classic distributed file systems like HDFS. So essentially, you have the master node, which is dealing with the metadata service, which is similar to name node in HDFS context. You have the Alluxio workers, which are really handling the data IOs, the data on the data path, which is similar to the data nodes in the HDFS context. And one interesting thing here is in Alluxio is designed to provide data locality, and it's not really designed to provide data persistency. So that's one very fundamental difference between between Alluxio with some other distributed file systems like HDFS, because the design different. This informs the design and implementation a lot. For example, in this architecture, one really unique thing is called under storage, which is on the right-hand side. And this is the place this is the service provides the data persistency for Alluxio. And Alluxio only provides the data which is useful or very useful for the applications. That opens a lot of interesting optimization opportunities. For example, in HDFS, you have to really worry about how many replications I have for this data replica, even it's not really used, but I don't want to lose my data. At least I want to keep 3 copies of this data. However, in the Alluxio context, this data replication is very dynamic inside the Alluxio space. If you have more data, access on this file, fine, let's make it into Alluxio, make it into the memory tier, or even make more copies, replicas for this particular data. And on the other hand, if the data is cold, no one is accessing them at all, then they can be evicted from Alluxio space to leave the space for other hot data. So this becomes very useful, especially for applications very elastic. So you can deploy Alluxio with some ephemeral or dynamic workloads like Spark, because Alluxio, in this case, if you use it as a read cache, it's not really stateful. And this becomes more and more useful, especially in the case like more workloads orchestration frameworks getting more popular to manage all the workflows. Next. And you can, because this 2-tier design with the Alluxio data in the Alluxio space versus in the persistent layer in the end storage, you can have different data flows in Alluxio. So when applications read data or write data via Alluxio client, you can choose different modes. For example, if the data is read from Alluxio, but it's not in Alluxio yet, this is the first time you touch the data, so there's no cache, and you can say, oh, I want this data to be cached in Alluxio for follow-up reads. Or you can skip Alluxio because you know this is a one-time access, and having this data in the Alluxio space is not helpful. And it's similar to the write scenario. You can control the data by passing some flags. You can control the applications to write data only to Alluxio or to only to the end storage. Or you can do synchronous write to both Alluxio and end storage, or writing to Alluxio first, then asynchronously write to the end storage. Next. So let's see how you can control the data access from Spark if you're a Spark users. Next. If you write an RDD, like for example, a lot of users are using RDD to Spark RDDs as the basic way to use data in Spark. You can save the RDD into Alluxio space, just like save a text file or object file with passing a Alluxio pass. And if you read RDDs from Alluxio, it's basically just restoring this RDD using sc.text file or sc.object file with the Alluxio pass as the argument. So it's very easy. You can use Alluxio as a normal data pass, file system pass in Alluxio in Spark land. Yeah, it's a similar case for using and writing and reading data frames in the Spark land. You can do df.write Parquet to export your data frame as a Parquet format, Parquet file into Alluxio pass, or you can read this data, a Parquet data, using sc.read and .parquet to restore the Parquet files, import the Parquet files as a data frame in Spark. Next. So let me go through a few use cases like why it matters when you are running Spark to read and write using Alluxio. So let's see first, if you are using Alluxio without, if you're using Spark to talk to HDFS or Amazon S3 directly, and it's possible that 2 different Spark contexts are reading the same data, but the problem is because the the data, if you cache the data into a Spark context itself, it's only visible to that Spark context. So if you have the data cached in the Spark memory for 2 different Spark jobs, then you will have 2 different copies for the data in memory. So you double the memory usage. And also the sharing the data can be slow. You share data first you dump the data first to S3 or HDFS, and then the next Spark job is picking this up and putting this in memory again, and so it goes through the network or disk I/O again. Next. So with Alluxio as an in-memory caching layer, so it becomes very easy. The first Spark job can simply write the data into Alluxio in memory if you configure Alluxio using memory as the main resource. And the Alluxio in the background can persist this data to HDFS or S3, whatever end storage you choose. And next, the next phase of this pipeline, the Spark can pick up this data and make it through because it's already in memory, it's going to be very fast. And also, you only keep one copy of the data in memory, which is in Alluxio, and you get the memory resource consolidated. And in this way, you can have your data your Spark jobs more robust and more being able to handle more data. Next. So the next benefit of having Spark with Alluxio is about data resilience. So you have the Spark job running, and you cache this data into Alluxio or Spark context memory. And once the Spark job crashed, can you press? Next. Once the Spark job crashed, and you will have all the data in the same Spark context lost, because there's no way for you to get this data out. It's only visible to that single Spark context. So next. And you just lost all the data. Yeah. So with Alluxio, let's see what's happened. With Alluxio, you can Spark can save the data, checkpoint the data to Alluxio. And even your Spark job crashed, which can happen because the bugs introduced by the applications or something is wrong because of resource contention. So even in this case, Spark jobs crashed. You can see that from the animation. And you still have data checkpointed into Alluxio in memory. So that means in the next step, if you launch Spark again, you can just read it from Alluxio space directly. Yeah, so I talked about these benefits, and there are also a lot of performance tuning tips related to how to run Spark with Alluxio. So one key difference in making making Spark jobs running faster is to really improve the data locality. And there are different concepts related to Spark, how you can enable the data locality. You have to make sure the Spark executor has some data it can access data locally to Alluxio, and also the task local. And also you need to prioritize data locality in the Spark scheduler. So you can see the bottom, the link to dzone, one of the articles talking about how you can ensure data locality by tuning Spark with Alluxio. And another very important tuning tips about running Alluxio with Spark is the load balance. And what we see in the past is that block size can affect how Spark schedules the different tasks. So you can definitely have a smaller block sizes in Alluxio to make this easier, make the scheduling work easier. And also you can tune the executor numbers and also some other Alluxio specific tuning tips like using the deterministic hashing policy to load data from UFS. So once the data is load balanced, that turns out very helpful for Spark to achieve good performance. And that's how Alluxio can help, not just in caching data, but also make the data more load balanced in the input phase for Spark. Next. So we will share some real-world use cases, and we will use a top-tier Telco company as the example how you can leverage Spark and to do a very good job in the workload orchestration. And also we'll talk about, so Yonggang will cover this part, and I will talk about how Alluxio can help the data orchestration in their workloads.
Right. We have talked a lot about how to scale the Spark, and also how to do orchestration. Of course, we come from a different angle. Alluxio and Ben talk about how to orchestrate the data. Well, I have talked a little bit about orchestration on the workload and application. And here is a scenario we bring both data and workload orchestration together. And this is a very large telecommunication customer, and they have hundreds of millions of subscribers. And they have local branch at a different state and the province, and they have initiative going on to centralize the IT infrastructure and also bring all the data from different regions together to headquarters. And over there, they don't want to have more silos. They want to have a consolidated sharing environment so that they can have higher utilization, have a better application, SLA, and also access to all the different type of data from different regions. Over there, they need a data orchestration capability and also need agility and the performance. So essentially, what
Hello? Hang on, folks. I think we have a little technical difficulty. Just give us a second. We're going to give Yonggang a couple of minutes. I think we're just having a little technical difficulty. In the meantime, I do want to mention that if you're interested in these types of topics around data and AI platforms, whether it's with open source technologies or around cloud, check out our upcoming event, the Data Orchestration Summit on November 7th. I will also paste the link into the box below. We have a great lineup of speakers, and we hope to see some of you there. Yonggang, do we have you back?
So before Yonggang is back, maybe I can pick a few questions on the Slack channel to answer. So one question on the Slack raised on Slack channel is Alluxio running on IBM Power? So actually, this is a good question. I think Yonggang may have more context about this, but as long as, for example, your environment can support JVM, Java 8, and you should be able to run Alluxio, support Linux and the Java, and that should be sufficient to run Alluxio, because Alluxio is just like the other popular open source systems in the data ecosystem. It's written in Java. So I believe IBM Power can run Java, so that should be good. But Yonggang can correct me or in later. So next question from Carl Dupins is, how well does Alluxio work with Teradata as a system warehouse storage? Okay, so the question, I think here I want to clarify a little bit right now, is Alluxio you can think is a logical file system building an data orchestration as a logical file system to orchestrate files and objects in the external storage system like HDFS or S3. And as far as I understand, Teradata is not really like a file system or object stores, but I do see people using Alluxio with Teradata. They need to write some kind of like jobs to exporting data from Teradata into Alluxio space, and then let Spark to read data from there. So one of the example is from Berkeley Bank, and they're using Alluxio as a caching layer for Spark with the data originally in Teradata. And what they found is that using Spark to talk to their Teradata is kind of very slow, especially during their peak time. So that's why they want to leave the data first into Teradata, and then they can go through Spark to use Alluxio as the data input. Okay.
Great. I think we have Yonggang back.
Yeah, my apology. Somehow
no problem.
my local phone line got disconnected, and I couldn't dial back. And right now I'm on my cell phone. Hopefully you can hear me clearly.
Yep. Go ahead. Thank you.
Yeah. Thanks, Bin, for to chime in. So this is essentially what we have done, and we help the customer build this integrated architecture, the data from HDFS and the different source, and We use Alluxio to create a caching layer and provide data orchestration, and then use Spectrum Conductor to create a multi-tenant shared Spark service environment. Over there, it provides a better performance for Spark application and also provide a better HA and reliability. It provides multi-tenancy so that different applications can share the same infrastructure and still with a guaranteed application SLA. One example is one of the application is a revenue sharing application, and over there they only need to run 6 days. After the 6 days of running this revenue sharing application, the same environment can be performed. So this is a benefit of.
Cool. Yeah. So the next slide is really about in this top technical company how it is using the Alluxio as a data orchestration layer for agility. So on the left-hand side, we put 2 different architectures, which is before and after using Alluxio as a data orchestration. So previously they have 2 different or multiple different HDFS clusters, and sometimes they're building very important business logic jobs to handle very important business logics. So sometimes they need to read data from different HDFS, and sometimes it's even like in a higher layer, like reading from the Hive table representation. So the problem is once their Spark is reading from the remote and the Hive tables, it becomes very slow. And also because they see the load balance problem, they have a lot of small files, or sometimes it's not really well load balanced across in the ETL. So they have to run some ETL jobs first to export the data to the main HDFS and Spark cluster to get a faster performance. So after that, they explored Alluxio as the data orchestration layer. They found Alluxio here provides 2 very important values to them. One is to provide a single namespace for their Spark jobs to access the different data sources freely. And with also, they have to bring the data local because Alluxio can cache the data closer to Spark jobs and to accelerate their Spark jobs. So on the right-hand side, they provided some benchmark for running some query. If it's running on Hive directly, it takes more than 100 seconds. And then they run this by having the data exported to HDFS first and run Spark on top of that. So it takes much faster than the Hive performance. It's 33 seconds. And then one thing they said is to use Alluxio as another caching layer below a Spark for the data and also solve the load balancing problem. And they have this 3 seconds, which is 30 times faster than the original Hive queries. Next. Yeah. So I think we're running out of time. So this is basically one takeaway slide from, if you're really curious about what Alluxio is, it's open source, and it's originally from the UC Berkeley AMPLab as a research project. And we have our Slack channel. You're welcome to join the Slack. And next slide. So as we mentioned by the host, we have a data orchestration summit ongoing in November 7th, in Computer History Museum. So if you're in the Bay Area and you'd like to hear more talks like the topic we're covering today about running, like what's the right data architecture in the cloud, how to run Spark, how to run Presto, TensorFlow in the cloud architecture, and also we provide a lot of use cases and also the free hands-on labs on Presto and Alluxio. You are welcome to join us, and we have very strong lineup, and you will have the registration code for Meetup for 20% off, and the prices are also pretty low. Yeah.
Okay, great. So I know we're coming to a close now. We've already passed our slot at 11 a.m. However, we still have a handful of questions here. So we are going to hang around to address the questions, but thank you, attendees, for joining us today, and a special thanks to our wonderful speakers, Yonggang and Bin Fan.
Thank you, Amelia. Thanks, Yonggang.
Thanks.
Thank
Yonggang,
you. Thank you all.
if you don't mind, we can hang around for just 1 minute. I want to bring up this question we have here, which is if we build a data bank from Teradata in Alluxio, and if we use a lot of SQL joins, would they all happen based on flat CSV files? Do we need more context on this question?
Yeah, we get to understand the relationship between Teradata and also Alluxio and Spark. Is the Spark directly access the Teradata or through other storage?
Yeah, so I would say like I need a little bit more context on this, and feel free to join the Slack channel and we can follow up there. But in a high level, I think we see a lot of benefits having Spark and Alluxio in this context to faster processing the data. And actually in the latest, in the next release of Alluxio, we're providing a new feature to compacting like CSV files into columnar format, like for example, Parquet for Spark or Presto to process. So that typically turns out very good for performance by storing the data in the right in a more computation friendly format. So we can definitely follow up on the Slack channel.
All right, great. Well, thank you guys again. This is a wrap.
Okay, thank you all.
Thank you.
Thank you.